Welcome to Brain Science, the podcast that explores how recent discoveries in neuroscience are unraveling the mystery of how our brain makes us human. I'm your host, Dr. Ginger Campbell, and this is episode 143. My guest today is Dr. Elkhonon Goldberg, who was actually one of my earliest guests back in the summer of 2007. Today we will be talking about his new book, Creativity, The Human Brain in the Age of Innovation. As always, you will find complete show notes and episode transcripts at brainsciencepodcast.com. You can send me email or submit audio feedback at speakpipe.com/DocArtemis. You can also use the SpeakPipe app on your smartphone. Before we go to the interview, I want to make an important announcement. Starting in April 2018, I will be doing a monthly live session on Facebook. I will also record these sessions for premium and Patreon supporters. I will explain the details during my announcements at the end of the interview. For those of you who are new to the show, I encourage you to continue listening after the interview is done because I will also be reviewing the key ideas. Welcome back, Elkhonon. It's hard to believe that it's been over 10 years since we last talked.
Indeed, so I'm delighted that you have not forgotten me.
Since it's been so long, would you mind starting out by just telling my listeners a little bit about yourself?
Yeah, I'm Elkhonon Goldberg. I am a neuropsychologist and a cognitive neuroscientist. I'm currently clinical professor at the Department of Neurology at New York University School of Medicine and director of the Luria Neuroscience Institute, which I started. I live an eclectic life. I am a clinician and I see patients with various forms of brain damage, ranging from dementia to traumatic brain injury to stroke to neurodevelopmental disorders. And I'm also an active researcher. I conducted research in cognitive neuroscience, and I've written several books, including the one we're about to discuss.
And where did you come from?
I was born in a country which no longer exists. I was born in the Soviet Union. I was born in Riga, which is now the capital of a separate country of Latvia. And then I lived in Moscow for many years. I'm Jewish, but Russian is my first language. But I've lived in the United States for many, many years, actually for most of my life, since 1974. And I live in New York with my dog, Brutus.
I thank you for sharing that information. I appreciate the fact that in all your books you share some of your background, including what you learned from your mentor, Luria, and it helps us to get a little, I think as Americans, appreciation that science is going on all over the world.
I think it does. In my own kind of experience, knowing something about the author of an idea or a theory helps me understand to grasp the essence of the theory. So I think that having this personal background is not just a distraction, but in fact helps understand the essence of one's thought processes.
Especially since many of your key ideas started when you were a young man.
Correct. That is actually true. Yes.
So when we last talked, we focused on your first two books, The Executive Brain and The Wisdom Paradox. What motivated you to write this new book about creativity?
Well, since we're talking about my old books, there was something that happened in between.
Okay.
And that was a second edition of The Executive Brain titled The New Executive Brain, which came out in 2009. And I think that it's also a good book. It was conceived, I was approached by the publisher of the original Executive Brain asking for an expanded edition, which I provided, and this expanded edition turned out to be so substantially expanded that we decided to treat it as a separate book and not just merely as a second edition of an old book, and gave it a somewhat different title, The New Executive Brain, and it's a book about the frontal lobes and executive functions. But by now, it's no longer a new book. It's also an old book. It was published in 2009. So very recently, I published a truly new book, a book on creativity.
Right, and that's what we're going to talk about.
Right.
One of the things that I appreciate about this new book is it expands on your previous writings, especially about the role of both the prefrontal cortex and the right hemisphere, parts of the brain which, forgive my metaphor, haven't always gotten the respect they deserve. So I was thinking maybe we could start out by having maybe a brief overview of our current neuroscientific understanding of these two structures, starting with the prefrontal cortex.
Well, the prefrontal cortex, of course, the irony that for many years it had been ignored, and the assumption had been that the tacit assumption had been that it's there mostly for ornamental purposes to support the cranium, I guess. And this tacit assumption, believe it or not, still persists in certain neurosurgical circles, where the surgeons, some surgeons at least, tend to treat the prefrontal cortex as expandable. And in fact, a number of years ago, I was invited by a young neurosurgeon to give grand rounds in her department of neurosurgery in one of the premier medical schools here on the East Coast, about the role of the prefrontal cortex, basically in order to disabuse some of the older members of the department of this notion that the prefrontal cortex is really not invested with any useful function. Of course, we now know that, quite the contrary, it's invested with very important functions. The functions linked to the prefrontal cortex are often referred to as executive functions by the analogy of the chief executive officer. And I personally like the analogy with an orchestra conductor even better. So the prefrontal cortex is to the rest of the brain was a conductor is to the orchestra, coordinating, organizing the functions of the rest of the brain into coordinated, goal-directed ensembles. And this, of course, is a very important function, without which no complex behavior can occur. And the prefrontal cortex emerged quite late in evolution and developed late in evolution. And it is among the last, or possibly the last, part of the brain to mature in ontogeny. So it's a very unique, very interesting part of the brain. And now, of course, as often is the case in science and in life in general, when the pendulum swings, it swings all the way. So far from being ignored, the prefrontal cortex now is arguably the most heavily researched part of the brain, the one which attracts the most attention of cognitive neuroscientists.
Good. And we'll talk about some of the specific things that you talk about in your new book in a minute. But what about the right hemisphere? There's a lot of popular image about the right hemisphere, but mostly what it really does is much more, I think, nuanced and more important than the mythology.
Right. Well, again, the right hemisphere in many ways shared the fate of the prefrontal cortex. For many years it was ignored. I mean, this designation dominant hemisphere versus subdominant hemisphere, the right hemisphere being subdominant. And that, of course, carries the implications of kind of a lesser hemisphere, less important hemisphere. And then more recently, a certain kind of a tabloid mythology coalesced around it, and people think of it as the seat of creativity, seat of insight, seat of artistic abilities. And of course, such tabloid simplifications are just that, tabloid simplifications. But what does seem to be the case is that the right hemisphere has a preferential relationship with dealing with novelty. So when the organism is faced with a situation which cannot be tackled readily with any of the previously developed cognitive strategies and representations, this is where the right hemisphere appears to play a definitive and decisive role, and it had this particular ability to deal with cognitive situations to which the organism's past experience did not prepare it.
Okay, and then how would you describe the left hemisphere, just for completeness?
Right, for completeness. And before we do that, let me just temper what I have said and will continue to say. It's always tempting to talk in such absolute statements, linking certain functions to one part of the brain and other functions to the other part of the brain. In reality, of course, we talk about subtle relative strengths rather than absolute affiliations of certain functions with specific parts of the brain. When all is said and done, brain is one thing, and any even moderately complex mental process involves much of the brain, possibly even the whole brain. Well, having said that, different parts of the brain do have different relative strengths, and just if the right hemisphere appears to have this particular ability to deal with novelty, the left hemisphere appears to be the repository of well-established routines, if you will, well-established, well-developed representations. And this distinction between the two hemispheres, based on the distinction between cognitive routines and cognitive novelty, and of course with the understanding that every even moderately complex mental process involves some kind of an admixture of both, okay? But still there is the relative division of labor. I think that it's a very powerful distinction, okay? For many years, and frankly, even to this day, neuropsychology is dominated, and cognitive neuroscience has been dominated by this notion that the left hemisphere, the language hemisphere, the right hemisphere, visual-spatial hemisphere, and this is not incorrect. This is true. But this is not the whole truth. And basically, you said earlier, and actually very accurately, that much of my work, certainly not all of my work, but much of my work is still guided by certain ideas which I came up with many, many years ago as a young guy at the University of Moscow. And one of these ideas was precisely that, this division of labor between the two hemispheres, whereby one is better dealing with novelty, the other one is better at guiding behavior by well-established representations. And the main reason why I began to think along these lines is because this notion linking one hemisphere to language and the other one to visual-spatial processes, basically I found kind of an incomplete and not fully satisfying already many years ago as a graduate student, believe it or maybe even actually as an undergraduate student, believe it or not. Why? Because this distinction does not lend itself to any examination of evolutionary continuities, okay? Mm-hmm. Because other species don't have language, at least not in its kind of rigorous, narrow definition, which means that any contrast based on the distinction between language and nonverbal processes has to be limited, is only meaningful if applied to our species, and is devoid of any meaning outside of our species. And I found that kind of intellectually troubling, because I thought that this duality of the brain is not unique to humans. Other creatures also have two hemispheres. So I thought that one should not ignore the possibility that some kind of a more fundamental principle of division of function between the two hemispheres exists, of which this distinction between language and non-language could be a special case. But this more general principle would be applicable across species and therefore lend itself to evolutionary kind of a consideration. And this is what prompted me to think about these things and look at some evidence, and came up with this distinction between the two hemispheres based on cognitive novelty versus cognitive routines. And within that framework, the preferential relationship between the language and the left hemisphere is just a special case of this more general principle. So this more general principle does not negate this notion linking language to one hemisphere and nonverbal processes to the other hemisphere, but sort of subsumes it as a special case of a more general principle. And that if you really look at how this principle is manifested across species, this is something that I attempt in this new book of mine, the creativity book that we're discussing today. It turns out that this distinction of labor between the two hemispheres indeed has been conserved across numerous species, so it's one of the very fundamental principles of brain organization. This distinction between neurostructures in charge of well-established routines and neurostructures in charge of dealing with novelty. And what's very interesting is that in artificial intelligence, or even broadly speaking, in computational neuroscience, when people who try to devise artificial neural nets capable of some powerful computations, this is something which has its origin in some work in the middle of the 20th century. Then it was kind of shelved as devoid of promise, and more recently revived under the name of deep learning, which is also a very trendy term, deep learning, related to multi-layered neural nets. And that's what this term deep learning means. And so in this field, this challenge arose how to reconcile these two tasks that a neural net has to perform, to store some previously accumulated knowledge and at the same time to have the ability to acquire new knowledge. So what turns out to be the conundrum was that as the neural net acquires new knowledge, some of the old knowledge is destroyed, okay? And so one of the solutions which has been considered within the body of this computational neuroscience or artificial intelligence, this idea that in order to kind of resolve this conundrum, these two functions should be somehow separated within the net. And it's possible that I believe that the Mother Nature kind of solved this conundrum by endowing the brain by the two hemispheres with these somewhat separate abilities. And then the challenge is to figure out what are the differences in the kind of a neural organization of these two hemispheres, which endow them differentially with these two respective abilities. So that's a very interesting and I think a very fundamental issue on the intersect of cognitive science and neuroscience and artificial intelligence and so on.
Good. So in your earlier work, you did a very good job of sharing the evidence for this point of view. But I'm curious, What do you see as the biggest growth in evidence in the last decade that supports this viewpoint? Is it in functional imaging or some other area?
Well, it's cumulative evidence. I wouldn't say that there was some kind of a qualitative paradigm shift along these lines, but there continues to be cumulative evidence supporting this point of view, and I present some of this evidence in the new book. And some of this evidence, and much of this evidence has existed in the literature. It was just a matter of sort of synthesizing it and assembling it, finding it in. The neuroscience is balkanized. Neuroscience has become such a big field. It's probably true for most fields of knowledge. But I would imagine that's true for physics and for chemistry and for every field. It's certainly true for neuroscience. It's become such a huge field that it's impossible to sort of keep all of it in one kind of a visual field, if you will.
Yeah.
So it's fragmented. But what I did as part of my research for the new book, for the creativity book, I really conducted literature review from very disparate areas of neuroscience, like animal neurobiology, for instance. My own work there has been limited to human studies, but here I decided to dig into some animal literature, and lo and behold, found a lot of evidence in support of this idea already there, again, basically validating this premise of the evolutionary continuity of this principle, which appears to have either been conserved across millennia, across multiple species, or is a product of what evolutionary biologists call convergent evolution, whereby the same principle is hit upon through independent evolutionary routes. But either way, it appears to be a very fundamental principle which holds across multiple species.
So how have your ideas been changed by emerging evidence?
Well, one way, I would say changed, but developed and evolved. One of the kind of directions in which my ideas evolved is that I felt that we were ready, finally, that I was personally ready to tackle this challenge of trying to figure out the neural machinery of creativity. I mean, had somebody told me like 20 years ago that I would be writing a book on creativity, I would have considered it fanciful, because until relatively recently, subjects like creativity were deemed to be outside the domain of serious science.
Mm-hmm.
And now it's no longer deemed outside of the domain of serious science. It's considered as accessible with the tools of modern neuroscience. And so one of the directions in which my own ideas evolved is that I felt that we were more or less ready, or at least more ready, to tackle these issues, which until relatively recently were regarded as outside the purview of serious science. And of course, that kind of segues into another issue which has always been of interest to me, and you started this conversation with me very aptly by bringing up this issue of the relationship between one's kind of a personal history and the essence of one's ideas. Well, I've always had this kind of a bifurcation of interest, probably somewhat unusual. As a child, as an adolescent, I was always interested in mathematics, and I was interested in the humanities, okay? And somewhat less interested in natural sciences. So the juxtaposition of interest in mathematics and the humanities remains with me. So even in my consideration of complex issue like creativity, I was very keenly kind of sensitive to the idea that you cannot approach it strictly within the domain of neurobiology or strictly within the domain of the humanities. It has to be approached somewhere they intersect. And that's what I try to do in this new book of mine.
With your background in mathematics, I guess that you were easily drawn to this growing importance of network theory within neuroscience.
Absolutely. Yeah, by way of full disclosure, and I talk about it briefly in this creativity book, that's where I started, okay? My earliest interest in neuroscience had less to do with experimental neuroscience and had everything to do with that which today is called computational neuroscience. In those days, the term did not exist. And we're talking about mid-60s, late 60s, in Moscow, USSR, at University of Moscow. And basically, I kind of fantasized about developing my whole career in that field. And my good mentor, Alexander Luria, was not sure what to do with this interest of mine. It sort of resonated with him a little bit, but not too much. that was my entry point into neuroscience, and my first independent research project involved neural nets in the absence of computers. Neural nets examined them as a paper and pencil exercise, so kind of analytic was a mathematical tools, because we didn't have any computers at University of Moscow in those days,
right.
Or at least we didn't have them readily available. So that's where my whole lifelong career in neurosciences and neuropsychology started. It started with neural nets, and of course then, through all kinds of twists and turns of personal circumstances, I ended up doing clinical work and experimental work as opposed to this more theoretical kind of a quasi-mathematical work. And at this point, this whole field of computational neuroscience has expanded to such an extent by leaps and bounds that there is no way for me to catch up with it in terms of kind of a mastery of the tools. But conceptually, I have remained interested in it and followed it and tried to digest it to the best of my abilities. And I think that at a very high level, it has always informed, or probably even more than informed, sort of shaped my thinking about the brain, even though my own hands-on work has been of a more experimental and clinical work. And I think that it comes through in my books. In this previous book, The New Executive Brain, there is a whole chapter on application of these ideas to computational neuroscience, and I talk about it a little bit in the New Creativity book.
Have you had a chance to get together with Olaf Sporns? He's the guy doing the Human Connectome project.
No. What's the name again?
Olaf Sporns.
No, I don't know this name. There are other people who do this work.
Well, he's written 2 excellent books that you would probably enjoy. I want to take a few moments to thank everyone who supports brain science financially via premium subscription, Patreon, or direct donations. Your support is essential because although this show started as a hobby, since my husband died in 2015, the income from brain science has become an important part of my budget. Without your support, I will not be able to devote the necessary time and energy to continuing to create new content. If you'd like to learn more about how you can help, please go to brainsciencepodcast.com/donations. I thought we might talk a little bit about some of the networks that we've come to appreciate that you talked about in the book.
Absolutely.
Okay, so I thought we could start with, could you just give us a brief overview of the 3 networks you talk about in your book? Executive, the default mode, and the salience networks?
All right. These networks are not of my design or creation. These are the so-called large-scale networks, which have been studied by neuroscientists using tools of functional neuroimaging mostly for quite some time by now. The central executive network is also sometimes referred to as the task-positive network, and presumably it is a network of areas which becomes activated when an individual is involved in a specific, particular, well-delineated task, as opposed to a default network, which is a very interesting network, which is a network which sort of reveals itself when an organism, an individual, is not engaged in any specific sort of externally imposed task, but is left to its own devices, his or her own devices, okay? And it's a very interesting network because until somewhat recently, may I say about 2 decades ago, the prevailing zeitgeist was that you cannot study brain at rest, that brain at rest is just a potpourri of all kinds of processes that you cannot control, therefore you don't know what exactly you are studying. And then the zeitgeist changed, and people concluded that there is a very important neuroscientist at Washington University in St. Louis, Marcus Raichle. He was one of the people very instrumental in kind of this ushering in this paradigm shift, and there were other people. Basically challenging this old notion and saying, yes, we can study the brain at rest and we can extract some very interesting and useful information. And basically what they extracted was this default network, okay? And then it has become kind of an older age, and now it's a very fashionable network. And the salience network, I think, is a bit of a misnomer. A salience and a misconception. The salience network was a network also described with the idea being that it's activated when the subject encounters something very important. In reality, I think that it's a novelty network, okay? Mm-hmm. That it's activated when there is a departure from what the subject has been doing and the subject encounters something new. So these are these very kind of fashionable networks, particularly the default network. I'm a little bit bothered by that, okay? These networks are great, but they sort of reek of this kind of a reintroduction of this old, tired notion of modularity. In the 70s and 80s, right before cognitive science morphed with neuroscience and the cognitive neuroscience emerged, there was this fashionable notion, the since discarded notion, that the cortex consists of a bunch of modules, each module delineated with strictly well-articulated boundaries, each invested with its own kind of a function and very little communication between the modules, okay? And it was a very fashionable notion. In my opinion, it was wrong-headed from the beginning. And in fact, many years ago, more than 30 years ago, in 1986, if I'm not wrong, a think tank was assembled at the Hebrew University of Jerusalem in Israel, which has what Princeton has, this Institute for Advanced Studies. And so at this Institute for Advanced Studies at the Hebrew University of Jerusalem, a think tank was assembled involving about a dozen of scientists from all over the world to discuss this issue, which at the time, this concept, which at the time was all the rage of the modularity of the brain. And I was kind of the bad boy of the group. I was the only one in the group who basically was saying that this whole notion was totally wrong-headed, okay, and predicted that it would be discarded. And it was discarded. It has been discarded. So my concern is that some of this infatuation with these networks is kind of a rekindling of this old modularity notion.
Right.
Not that these networks don't exist, of course they exist, but an attempt to kind of shoehorn all of them into a finite and relatively small number of this canonical network, I think reeks a little bit of this modularity. So yes, I'm very intrigued with, and I say so in this book of mine, I take these networks very seriously. As I said, I was not the one who invented them, but I follow this literature relatively closely, but with this bit of a tongue-in-cheek.
Well, that's a great lead-in to what I was thinking about asking you next. One thing you mentioned in the book that was new to me was this dynamic network connectivity.
Right.
Can you talk a little bit about that? Because in a way, that almost says the opposite, because if the networks are going to be dynamically changing, then trying to tie them down to discrete ones might be the wrong way to go.
Well, either a wrong way to go or not the only way to go. In other words, there may be multiple principles and multiple modi operandi at work in the brain at the same time. Now, this dynamic network connectivity is not my idea, it's not my concept. It is something discovered and described by Amy Arnsten at Yale University. And at Yale, they have a very strong tradition of neuroscience. And Amy was a student of the late Patricia Goldberg-Rakish, who was arguably one of the most important neuroscientists of the end of the 20th century. She died prematurely and tragically in a car accident. But she, the one, Amy Arnsten and her associates, came up with this notion. And I was absolutely excited when I read about it. And I was excited about it because it sort of filled the gap which I thought had to be filled. You know what I'm saying? I sort of suspected that something like that had to exist in order for this process called working memory to happen in the brain. And so when I read about it, I was very, very excited. And I began to fantasize about it. And some of my fantasies, arguably far-fetched, are shared in this book. And in this book, I'm saying, actually, some of what I'm saying may be lunacy. So some of my more reserved colleagues may consider some of what I'm saying lunacy. But I'm saying it just in case it turns out to be prophecy, right? So it may be a lunacy, it may be a prophecy, or somewhere in between. Every prophecy at some point is regarded as a lunacy, I guess. Basically positing that this process which Amy Arnsten described is a real process and that it plays a very important role in the brain, plays a role in how knowledge is re-represented in the prefrontal cortex as part of this frontal cortex being able to direct the activities of the whole brain.
Do you mind backing up and just tell us some of the key ideas of Arnsten's work here?
Well, the key idea is, as I understand it, is that there are some processes in the brain which allow the assembly of temporary neural networks very rapidly and sort of fleetingly in a way which does not depend on the proliferation of new synapses. You see what I'm saying?
Mm-hmm.
So the process is very rapid and very fleeting. these networks come and go. And I do not even purport to understand all the biochemistry that Dr. Arnsten and her colleagues describe. So my understanding of their discovery is sort of a kind of a macroscopic high-level understanding, and I hope that it's an understanding and not a misunderstanding. But this is in a nutshell what these networks are.
Okay, yeah. I downloaded both the papers that you referenced in the book, and I haven't gotten through them yet because you're right, there's a lot of biochemistry in there. But I guess for the purposes of our listeners, we're talking about a mechanism that's faster than growing new synapses.
Much faster.
Much faster, and so could explain something like working memory, which works on a very short time scale.
Yeah, because you see, the problem that I saw with working memory is that, okay, this classic work on working memory by Jacobs and by Pat Goldman-Rakish involved some relatively simple experiments with monkeys where some information was presented and the monkey had to keep it in mind for a relatively brief period of time in order to manage its behavior. Well, and that's all fine. And then the idea was that this information is somehow transmitted to the prefrontal cortex. That's all fine. But in humans, but probably in many animals also, our working memory is not limited to the manipulation of this kind of a relatively small amount of information, which has some sensory inputs, okay? Now, we are having this conversation in real time as we speak, and you keep in your mind the thread of your thought and my thought, and I keep in my mind the thread of your thought and my thought, okay? But basically what we're doing, we are kind of accessing some content of our long-term storage, right?
Right.
And what bothered me is that it was not clear what the mechanism was of accessing long-term store in this dynamic, kind of a basically fleeting and constantly changing way. These animal models where the content of working memory was some sensory information did not completely explain how it could be generalized, how it could be expanded to explain how working memory interfaces with long-term store, which, in a regular human being, in a regular primate, but certainly in a regular human being, contains huge amount of information. Mm-hmm. You see what I'm saying?
Right.
And when I read about Arnsten's work, that sort of filled this gap. I was thinking that my kind of ruminations along these lines were kind of devoid of any particular clarity. But I was thinking that something like that had to exist, you know what I'm saying? And then she came up with this work, which sort of resonated with my sense of incompletion and sort of completed the picture.
Right, that makes sense. We're getting short on time, but did you want to say anything more about non-human brains and what we've learned about, say, the laterality and that sort of thing, how that fits in to your ideas?
In this new book, I did something, I sort of visited the non-human neurobiology in much greater detail than any of my previous books. And basically, make an argument that division of labor between the two hemispheres and this bilaterality, this duality of the brain is a pervasive feature of the brain throughout multiple species and genomes. And I make the case that this division of labor, whereas one half of the brain somehow is more adept at dealing with novelty and the other is more adept at dealing with routines, is a very fundamental and a very pervasive feature of the functional organization of the brain across multiple species.
So I guess I should ask you, I've been sort of avoiding this question because it's almost too big of a question, but since we don't have time to try to define creativity, which you explain well in the book, you sort of talk about how it interrelates with novelty. And what do you want to say about creativity, just to give my listeners a feel for why they should read the book and learn lots more? Because I just don't feel we can do it true justice.
Right.
I do want to give you a chance to talk about it since it is the main driver of the book.
My book is a Trojan horse, as I explained in the foreword. I talk there about creativity, but I talk there about a whole lot of other things. And some of these other things may be as interesting as creativity. I talk about artificial intelligence. I talk about how this ever-increasing rate with which innovation is introduced in society will affect the way brains age. I talk about a number of things there. But basically, creativity, I think that in order to tackle this issue of creativity, one has to realize, or one has to embrace the notion, as I did, that creativity is basically, and it sounds like an oxymoron, what I'm about to say. Creativity is a derivative construct. It's almost oxymoronic to refer to creativity as being derivative, but it is. It is really a complex process or a range of processes of many, many moving parts. And we are, in understanding creativity, we are probably better off examining these different moving parts first and only then trying to figure out how their interaction leads to this kind of a magic act of creativity. And that's what I'm trying in the book.
I think you succeed.
I hope. And if we have a few more minutes, what I would like to address, we said in the beginning, where it's somewhere in the course of this interview, that I always operate on the assumption, and what I think is a new and innovative feature of my book, because there have been other books about creativity, but these other books were either strictly about biology or individual kind of a condition, or they were strictly of a kind of a more social variety. And in my book, I try to interface these two perspectives. And I think that it's very important. And in that, I know that it's important. I'm a product of two different cultures. My formative years were spent in one culture in Russia, but the bulk of my adult life has been spent in this country, in the United States. So this cultural and multicultural perspective is very important to me. So I think that to understand the creative processes, one needs to examine it in a multicultural, cross-cultural context. And this is what we're trying to do. And we have started a project in Southeast Asia, in Indonesia of all places. In fact, it's almost 7. At 8 p.m., I'll have another conference call. I'll have a conference call with some people in Yogyakarta, Indonesia, at Gajah Mada University. It'll be 8 a.m. their time, 8 a.m. their morning, next day their time, at 8 p.m. our time. They're 12 hours ahead of us. And we are in the process of developing a collaboration looking at the mechanism of artistic creativity in Indonesian artisans in Bali, which is a renowned hub of artistic creativity, and in Yogyakarta, in Java, which is also a renowned hub of artistic creativity. So I think that this cross-cultural perspective is extremely important if we are to understand the mechanisms of these universal phenomena. And that's what we're trying to do now.
Well, I have to say that I get sent lots of books about creativity, and I rarely read past the first chapter because there's no science there. And so I really enjoyed yours very much. And back in the wisdom paradox, you wrote about the importance of embracing novelty and learning new things as we get older. In this book, you bring up some surprising statistics about the incidence of dementia. Would you share those with my listeners?
Well, surprising indeed that it appears that contrary to many kind of a doomsday scenarios, the incidence of dementia is decreasing, both in the United States and in Europe, in Western Europe at least. Not prevalence. The prevalence is probably still on the increase just because people live longer.
Right.
But the incidence, the rate of the appearance of new cases is coming down. And also the age at which people develop dementia is coming up. In other words, if one is destined to become demented, people become demented at a later age. So this kind of a gain is considerable. It's a gain measured in several years. And this is a mysterious phenomenon and sort of unexpected phenomenon. And kind of the obvious explanations don't seem to completely account for it. Yes, healthcare is getting better and risk factors for cerebrovascular illness are better controlled and all that. But even if you control for all these factors, it does not seem to explain this phenomenon. And I propose, in a strictly speculative way, again, I may be completely wrong, but maybe not, that this is a reflection of the fact that the rate at which people are exposed to novelty, even older people, is increasing exponentially. And even those of us who basically are mentally lazy people, and there are a lot of mentally lazy people, those of us who really don't welcome novelty, who try to eschew novelty, cannot escape being exposed to novelty and being sort of forced by society to constantly learn novel new things. You're younger than I assume, but I certainly was not raised with computers, let alone internet in my environment. Something that, if you look at all these older people toiling very confidently on their iPads and using their smartphones, and doing it very well and very confidently. This is not something that they grew up with, and it's not even something that they were exposed to in their middle age. It's something that many of them have been exposed already in their advanced years, and I think that it may be sort of an inconvenience that you can no longer coast on your mental autopilots all the time. But I think that it does wonders for our brains and basically confers some protective effect. I mean, so this is the idea that I developed in this book. Is it right? Is it wrong? I don't know. But it's an interesting idea to explore.
I agree. So I want to ask you one last question, since when I interviewed you the last time, I was just getting started, but since then I've sort of gotten into the habit of asking my guests this very popular question, which is, can you give me some advice for students? And I mean students interested in going into any kind of neuroscience field.
My advice is go into neuroscience. It's a fascinating area of research. It's a fascinating area of inquiry. By all means, go into it. This is my advice.
Okay. Is there anything else you want to share before we close?
Well, I'm delighted that you are interested in my book, and I hope that your audience will read it and find it interesting. And I also hope that it's not my last book. We'll see.
Well, I hope it's not your last book, too, because I really enjoy your books, and I look forward to reading the next one.
Well, thank you very much, and thank you for your interest.
You're welcome.
Be well.
Dr. Goldberg's new book, Creativity, the Human Brain in the Age of Innovation, certainly stands alone and is appropriate for readers of all backgrounds. I want to touch on a few key ideas. First, we talked about the role of the prefrontal cortex without actually specifying what it is. The prefrontal cortex refers to the parts of the frontal cortex that are actually in front of or anterior to the motor part of the frontal cortex. The reason why its functions were not appreciated early on is that if you stimulate either the sensory or motor cortex, you will see either movement of a particular body part or generate a sensation in that same region. This doesn't happen when the prefrontal cortex is stimulated because its functions are much more complex. Today, we talked a little bit about the importance of the prefrontal cortex in executive function and working memory, but in previous episodes, we've also talked about the importance of the prefrontal cortex related to the fact that it is in two-way communication with almost every other part of the brain. This appears to be essential to its function, which is why Goldberg compared it to conducting an orchestra. There also appear to be differences between the functions of the left and right prefrontal cortex, but we didn't get into that today. However, we did talk about the overall difference between the right and left hemisphere. Goldberg argues that while the left hemisphere focuses on well-learned or routine tasks, the right hemisphere is involved in dealing with novelty. We didn't get into the evidence for this, but I will mention that much of the evidence has come from functional imaging, both MRI and PET scans, that show a gradual shift in activity from the right to the left when a new task is learned. This brings up another topic that I've mentioned often, which is the importance of experimental design and how it is influenced by theoretical expectations. The only way one could uncover this shift of activity from right to left is to do functional imaging at different times during the learning of a new task. The difference would be missed if you're imaging during an already well-learned task, such as language, or if you measure at different times, but then averaged everything together. Let's consider the example of language. It's well established that the left hemisphere is essential for language tasks involving both semantics and syntax or grammar, while the right hemisphere is essential for processing prosody, or the sound of speech. This actually fits Goldberg's paradigm perfectly. Semantics and grammar are skills that have become automatic. What about prosody? Think about it. Isn't this the thing that is most likely to contain novel information, such as that carried by the tone of a voice? We will have a chance to explore these ideas in more detail next month, because the episode is actually going to be about language and the brain. Another topic that is very important in Goldberg's new book is his discussion of networks. And though he seemed to downplay the importance of networks during our conversation, this has been a consistent theme for many guests in recent years. If these ideas are new to you, I encourage you to go back and listen to the interviews of Dr. Olaf Sporns. You might also enjoy episode 124, where I talk with Dr. Michael Anderson about his neural reuse hypothesis. One of the key themes there was the idea that neurons can actually participate in multiple networks. 3 of the networks that are currently receiving much interest are the Central Executive Network, the Default Mode Network, and the Salience Network. I want to expand briefly on my discussion with Dr. Goldberg by noting that the Central Executive Network is also called the Cognitive Control Network because it's very active during outward-directed tasks. This is in contrast to the Default Mode Network, which seems most active when the brain is at rest relative to the outside world. In his book, Goldberg explores the evidence that these networks appear to have complementary roles when it comes to creativity. We didn't talk as much about salience as I would have liked, but one of the points he made in his book was that salience may be generated either internally or externally. This is important when designing experiments because it can affect the results. When you hear about salience, dopamine is the neuromodulator that gets all the press. But there are a couple of ideas that are often ignored. One is that there are multiple dopaminergic pathways, and the other is that the effect of dopamine depends on which dopamine receptor it encounters. This is one reason why you might read apparently contradictory statements about what dopamine does. So we hear about dopamine as the reward chemical. But besides salience, it's also involved in arousal. In the prefrontal cortex, it appears that dopamine helps to signal that a stimulus is important or salient, while the neurotransmitter norepinephrine signals novelty. Returning to the idea of different dopamine receptors, Goldberg suggests that dopamine may play a role in what he calls maintaining the adaptive balance between stability and flexibility. Finally, Goldberg alludes to the fact that dealing with novelty is not unique to humans, so it is not surprising that so-called laterality, which is to say the difference between the right and left hemispheres, is not limited to humans. In fact, it's not limited to primates or mammals. Similar differences have been found in birds, even though they don't have the cortical layers that distinguish the mammalian brain. Well, what about creativity? Dr. Goldberg argues that we now have the ability to study several of the important building blocks of creativity. His book makes a valuable contribution to the growing literature in this field. I want to take this opportunity to thank everyone who makes the effort to send me feedback, either via email or audio feedback, either via email at brainsciencepodcast@gmail.com or audio feedback via speakpipe.com/DocArtemis. In a minute, I'm going to outline how I hope using Facebook Live will make it easier for you to give me feedback. But first, I want to comment briefly on how I choose the books that are featured on Brain Science. As you might imagine, aside from listener suggestions, I receive several books every week from various publishers and authors, more than I can ever hope to read, let alone feature on Brain Science. For that reason, over the years, I have tended to favor newly published books, but although my choices are admittedly idiosyncratic, I do follow 2 basic rules. The first one is that the contents must be consistent with current scientific knowledge and provide adequate references. Second, there must be one or more key ideas that I think are important for listeners of all backgrounds to know. Of course, the book must also be well written, but I think that's almost too obvious to mention. Creativity, the Human Brain in the Age of Innovation by Elkhonon Goldberg fits all these criteria. While Goldberg expands on his previous writings about the prefrontal lobes and what he sees as the true role of the right hemisphere, he also incorporates newer ideas about networks. The book is well referenced and can provide an excellent starting point for anyone just starting to read in the field, but it also presents enough new material for someone like me. I'm not going to bore you with the many reasons why books are rejected, but I will admit that if a book doesn't capture my attention within a few pages, it's probably doomed. So let's move on to this month's big news, Facebook Live. Never fear if you detest Facebook, but I'll get to that shortly. The basic plan is as follows. Starting in April 2018, I will be hosting a Facebook Live session on the first Thursday of every month at 8 p.m. Central Time. During the session, which will last 20 to 30 minutes, at least to start out, it will be possible for you to submit comments and questions. But since I know this time will not work for many of you, my plan is to record each session. These recordings will then be available to premium subscribers and Patreon supporters. What about the content? Well, we're going to start with a discussion of January's episode, which was episode 141 with Rodrigo Kian Quiroga. We talked about memory. If you have a question or comment about that episode that you would like to have discussed, you can also send it to me via email at brainsciencepodcast@gmail.com. In May, we will discuss episode 142 with Michael Graziano, and in June, we will discuss this month's episode. I've chosen this schedule because I know that many of you do not listen to new episodes the same month they are released. Thus, for any given month, you will know that the topic will be 3 months back. The featured episode is just the starting point. You can also submit questions and comments about other topics, which I will feature if time permits. If you ask a question that I feel unprepared to answer completely, I will save it for a future session. My hope is that over time, more and more listeners will participate either in the live session or by sending in comments and questions. In fact, if you send the questions in early, it will help me to prepare better responses. If you want to participate in the live session, it will be hosted on my personal Facebook page, and also it will appear on the Brain Science Podcast fan page. Over the years, I've had many requests to do live online events, but I've never been able to see how to make this worthwhile, given that there's no way to pick a time that will work for the majority of listeners. The beauty of podcasting is that you can listen whenever works best for you, even if that means binge listening once every 6 months. The reason I've decided to try Facebook Live is somewhat a matter of timing. I've been struggling to find a way to create more premium content without depriving listeners with limited resources. With Facebook Live, you will be able to access the live event for free. The recordings are intended to show my appreciation for those of you who support my work via premium subscriptions or Patreon. To learn more about these options, just go to brainsciencepodcast.com/donations. Naturally, it's my hope that this extra content will motivate more of you to support the show. As always, I appreciate your listening, and I hope you will share brain science with your friends. I look forward to our first Facebook Live session on April 5th, 2018 at 8 p.m. Central Time, and the next full podcast of Brain Science will be released on the 4th Friday in April. Thanks again for listening. Look forward to talking with you real soon. Brain Science with Dr. Ginger Campbell is copyright 2018 to Virginia Campbell, MD. You can copy this show to share it with others, but for any other uses or derivatives, please contact me at brainsciencepodcast@gmail.com.